it's called a scribble block.
Okay.
And so what the scribble block does, it makes random drawings on paper.
Okay.
And we made it out of this canvas box, and we have these markers that are like the legs for it that hold it up.
Okay.
And how it gets its energy, we have a battery, and we connect it to a motor, and this motor works as a fan, and it moves the box, and it
Okay.
draws drawings. Thank you.
Awesome. Thank you for sharing.
Girls, so next we have Shri. She's joining us from Haya Academy, and she's originally from India. Can you show your project?
So here I made a windmill, and I chose this project because around 15 people wasting a lot of energy and trying to stop them. But the new project, the results worth it. So I was trying to find projects in which could renew energy or electricity. I came up with I found this project as a windmill, and this is renew electricity. So I found this really, really interesting. So a problem that I faced was before I started building or constructing the motor was working perfectly fine. But as I built the whole model connected it to the computer, the motor stopped working. That made my project incomplete. Another problem I faced was the materials that were not available. Instead of the board, I had to use a block of foam. And I thought instead of using new cardboard for the panels, I thought of using old copy paste that was foam, so I could make the legs for the panels as it's working the same time. And if I do this project again, I would several times check the motor again. So that's what have this complete again. And I have a question. If as I said, the materials are really limited with Egypt, and Amazon can ship them. Here it's very difficult to ship. So are there substitutes for local materials that are available?
That's wonderful. I think that one of the things about windmill or air wind energy is it's actually becoming very, very popular as it relates to a renewable source of fuel. And one of the things we do is we actually have lessons that actually build windmills and actually use technology for sensors to actually monitor the progress, energy output, etc. And there are lesson plans using digital tools that we actually have available for use in the classroom. So it's good to see you working there. And I love the fact that you looked at the project and how you will continue to improve it, and thinking about ways in which you to tweak the work that you've done. That's the way in which we learn. So we overcome obstacles, we learn from what we've done. So it's amazing to see that in practice.
Thank you, Shri. So our high schoolers have been using the Microsoft Hacking STEM, and they've been working on a robotic hand. And
oh, great.
They just want to show what they've got to.
Great.
Hi, I'm Ken. And
Hi.
I'm Amina. We've done a robotic hand, and so basically we made a hand with sensor fingers, and so when we wear it, and when we move our hand, we can see results on the computer, percentages of how our hand is moving, and this hand works using the battery.
Yeah, absolutely.
The hand itself is, we made it from cardboard and straws. We also used the Arduino board to do this, and we also used the wheels were also the breadboards, and we used copper tape. This is our hand moving on the computer, and then this one's also.
Very good.
Yeah, some problems we faced while doing this project is that we made our sensors wrong at first, so we had to repeat a few fingers again. And
also, we were following paper instructions, and sometimes they weren't so clear, so we had to find the picture and try to figure out how to reach the results.
we also, another problem was first, when we were plugging it into the computer so that we can actually move it. In the beginning, it was not moving, and we later figured out it was because of the batteries and in here they were not when they needed to be changed. So now we actually just got it to work now.
I get you. Well, it looks like it's working great. I've done this project several times, so I know some of the areas that are tricky on the instructions. So it's good to kind of learn from that. We hopefully make the lesson super easy to follow, but there are some areas, especially with regards to applying the sensors and the copper tape that are they're a little tricky. One of the things that we've seen schools do who built the hand is actually use the same gears and mechanism to actually build other things using the same properties and the same glove for control. For example, I went to a school that actually built a dragon that you can literally, like a falconer would have the bird sitting on your arm. You can actually use the hand to actually almost do puppetry with the falcon or the dragon using the different pulleys and levers. So one of the things as you continue to do the lesson and get good at doing the hand, think about you can apply the same coding and the same work, but actually creating a different structure that does something else. That's something that I've really been amazed to see how schools apply the lesson.
All right, thank you, ladies. We got one more group that wants to share with you.
Awesome, thank you.
Hi, my name is Lena, and my name is Tia. My name is Maria. So we're also working on the robotic hand, and we also have multiple problems in trying to get it to work, and we haven't got it to work fully yet because one of the problems is it was actually on the website that this is another problem. In the data in section of the Excel worksheet, we get -1s for every finger. So that means that there's some connection that's reversed, and we still haven't figured that out yet. But we have completed building everything, and right now we're just troubleshooting to try and figure out what the problem is. So we built the hand out of straw, cardboard, and used string. And we connected each finger to a servo motor so it can pull the string and move.
Yes.
Also, we had some issues because the hand was very heavy, so it couldn't stabilize on the piece of cardboard properly. So we had to improvise and try to work around the issue, and we added glue to make it stronger. The cardboard would keep bending because of the weight of the servos and the straws, so we just added more glue to make it sturdier and be able to hold the weight of all the straws and servos. We also made the sensors, the finger sensors, and attached them properly. But we had some issues in the sensors because the wires connected to them used to break or move around, so it wouldn't properly work. We had to try to find a solution. So the main problem was there were wires were either too thick or they were too fragile. So at first we used very thick copper wires that were very hard to stick, so they couldn't stick between the pieces of copper tape. Then we used thinner wires and they worked, but the problem was they were a bit fragile, so we needed to be extra sensitive or else they would break, and they did break multiple times, but it was just a matter of removing a bit of the copper tape and attaching the wire again.
That's great to see. I actually think, by the way, the troubleshooting and the work you're doing is far more valuable than actually just completing the lesson based on the instructions and have everything work. Because you're getting to know a lot more about the mechanism, the trade-offs and the balance, etc. You're becoming so much better at understanding the dynamic because it didn't work properly at first. So I love the fact that you're using this as an opportunity to learn and deepen your knowledge, and I think it'll accelerate how you can innovate by going through the work that you're doing to troubleshoot.
Yes, exactly.
Thank you.
Thank you so much.
That's great to see.
I just wanted to mention that, first of all, it's early on in the year and we're scaffolding right now, so these students are just trying out the lessons as they are. Our aim is
Wonderful.
for them to get comfortable, and as you see, they're pretty perseverant, so we're hoping that they'll be able to innovate. Their next project will be something where they've learned from what they have and then bring it on to something completely new. Also, I wanted to mention that they've been doing a lot of substitute materials, so that's something that, maybe somehow we can figure out how we can use local materials instead of having to get things from abroad, because that took a lot of time for them to be able to facilitate.
I understand.
And the last thing is that I wanted to thank them because they made this this huge leap. It's a new thing in our curriculum, and the fact that we're able to use these lessons and sort of bring our own culture into them has been an excellent experience. I see them working in the iterative process. I see them learning from their own mistakes. And to me, honestly, the fact that I see them using the engineering design process is much more important than the product that we're going to show you today.
Absolutely, absolutely. Well, thank you. Well, first off, thank you for your leadership to expose your students here, but it's amazing to see their resilience and grit. And hopefully this is just going to fuel an appetite for how you apply tools and technology and teamwork to solve more and more complex problems, because that's what we need to unleash, not only in Egypt, but across the world, to help students solve some of the world's toughest challenges. That's what we're talking a lot about during the Skype-a-Thon conversations around the UN Sustainable Development Goals, and you're applying the kind of tools and skills that we're going to need to put student talent to work to make that change. So it's great to see. We're going to continue to build more and more hacking STEM lessons, so hopefully we can continue to fuel that passion through new lessons and experiences that we can bring into the classroom.
I'd like to see lessons from K to 12, because I know that we're only using the middle school standards, so I'd be more excited if we had it across all of the curriculums. That would be really good.
Yeah, that's good feedback. We actually brought in educators recently to actually build and diversify, and we're trying to think about range of technologies end to end, and think about the way in which Minecraft and the tools that we do in the code builder inside Minecraft can actually provide insight to have students test and trial activities as well.
That would be excellent. We're really looking forward to them getting a chance to innovate, and thank you. Thank you for all your support.
Oh, it's my pleasure. Thank you.
Yes, you're going to join a tour now with Mr. Abdurrahman at the Egyptian Museum, and we're going to join you on that tour, okay?
Wonderful. Thank you.
Do you
I'm looking
have any
forward to it.
questions, or maybe they have some questions?
Do you have some?
I don't know. Do you have questions? Yes.
Yes. Yes, you can.
Okay. Thank you all. It's been amazing talking to you.
Okay, I have one question.
Yes, please.
Shall we see a competition for the students about Minecraft?
Okay. Well, actually, so what we've seen with Minecraft is lots and lots of countries and schools are thinking about ways in which you can unleash students to design in Minecraft as a competition. One example is there's a nonprofit organization called Block by Block that works with departments of public works. So imagine in Cairo you have new parks, new bus stations, new public spaces that are being built every year, either new construction or being renewed and refurbished. So many countries work with students to actually use Minecraft as a tool to design public works projects. So you can actually work with your Egyptian or Cairo Department of Public Works to say, what are the big projects that are upcoming? And would you seek input from our students across Cairo to innovate and to build ideas, present their ideas to a deciding board, and then you can select the winning student to actually build that student's work in the real world in Cairo. Many, many countries have done similar projects like that, and it's a win for everyone. Your government department gets great input and innovation from students, they actually promote the work that they're doing to actually bring the communities together. Your students are excited because they can build something that they can see in the real world. And the community benefits because the project ultimately has the insight of great minds and students who are thinking forward. So it's a good way to think about it. We are excited about bringing those kind of things together more than having a global contest on Minecraft, because Minecraft is really a creation tool. So it's good to actually think about maybe looking at the creation to actually do real work in communities versus some abstract thing that we do at Microsoft. We are, though, introducing Imagine Cup, which is a tool we have for development with universities. We're bringing that into schools in K through 12 so we can get younger kids in that project. But that will be more about applying a range of technologies to solve problems versus Minecraft specifically.
Okay, thank you, Mr. Anthony, for your time. We are so happy today that we met you. Thank you for your time. Bye.
It's my pleasure. I was incredibly impressed by all of you, so thank you so much for sharing the work that you're doing.
Okay, Abdurrahman is ready. He's gonna...
Aywan here. Yes, Nelly.
Good morning, Abdurrahman.
Yeah.
Hello.
Good morning. Hello, Mr. Salcito. How are you?
I'm very good. Great to see you.
Yes. Yeah, nice to meet you also. So, are you ready for our amazing adventure in Egyptian Museum in Cairo?
I'm blown away. Let's see.
Yeah, I will show you some